cryogenic vial can remain in storage for years, but a weak purchasing decision can compromise traceability long before sample release. If the exact container, cap, code format, or production lot cannot be reconstructed, the problem extends beyond packaging. It affects accessioning, freezer mapping, retrieval, testing, audit response, and confidence in the sample record. Supplier qualification must therefore be configuration-led, not brand-led. Product families may include multiple capacities, thread designs, cap profiles, coating layouts, packaging formats, and sterility options. Evidence for one variation does not automatically support another. Every critical claim should be linked to the selected SKU, its closure, its marking method, and the conditions under which it was tested. The technical baseline begins with the physical container. Record the tube and cap materials, nominal and working volume, base geometry, thread position, closure profile, sealing features, sterile status, packaging quantity, and intended storage accessory. Then map the full workflow: mechanical freezer storage, ambient transfer, vapor-phase liquid nitrogen storage, manual retrieval, and warm side processing. This reveals where thermal transitions occur, where frost or condensation may affect scanning, and where closure handling introduces risk. Identity control requires equal precision. The qualification record should define the 2D code type, code location, sequence management method, reader environment, and software used for acceptance. Cap colors and side markings may support visual handling, but the primary control is the verified relationship between the code, rack position, sample record, and audit history. A disciplined approval process can be organized into 6 stages. First, establish exactly what is being purchased. Record the legal manufacturer, commercial brand, product family, item number, revision date, and complete configuration. Customized barcode sequences or cap colors should be approved before ordering. Second, compare supplier specifications with local requirements. Procurement, laboratory operations, quality, and data management teams should agree on non-negotiable boundaries for volume, closure, coding, storage geometry, documentation, packaging, and supply constraints. Third, verify critical performance evidence. Closure integrity records should identify the test method, pressure or vacuum condition, duration, sample set, closure configuration, acceptance criteria, and result. Temperature statements should distinguish storage conditions from transport conditions and describe relevant handling limits. Barcode evidence should cover the actual symbol, location, reader, rack, and environmental conditions. A successful room temperature demonstration does not establish readability after low temperature exposure. Fourth, assess sterility, cleanliness, and batch documentation. Claims involving e-beam processing, DNase or RNase status, endotoxin or pyrogen declarations, cleanroom conditions, packaging, and lot traceability all require defined scope. Company-level quality information must not be treated as product-level proof unless the documentation clearly supports that conclusion. Fifth, run a controlled workflow fit evaluation. Test opening and closing while wearing the relevant protective equipment, seating in the intended rack, retrieval from cold storage, scanning under representative conditions, and reconciliation with the sample management system. The purpose is to verify local fit, not create a broader performance claim. Sixth, establish receiving, deviation, and requalification controls. Incoming checks should cover item number, lot, packaging integrity, and required documents. Changes to closure geometry, code format, material, manufacturing source, supporting evidence, or packaging configuration should trigger documented review. A 3-tier evidence grid keeps approval decisions proportionate to risk. Critical evidence covers closure integrity, intended temperature context, code readability, and lot traceability. Missing evidence blocks routine approval. Major evidence includes material declarations, cleanliness documentation, packaging controls, and applicable quality records. Gaps require remediation or constrained use. Supporting evidence addresses customization, logistics, service, colors, and accessories. Reliable long-term storage begins with evidence tied to the vial that will actually be delivered. A controlled 6-stage workflow, evidence-based approval tiers, and explicit requalification triggers turn supplier selection into a defensible part of sample governance.